Hi class, let's take a look at problem 3D. Now, because the function actually has a tangent in the denominator, it's going to retain some of the properties of the basic tangent function. So for instance, the actual range of the function, it's going to be from negative infinity to positive infinity. Now, let me show you the graph just so we can take a look at what it actually looks like. And in this case, I provided one period of the function here. And as you can see, you can technically see that the function goes from negative infinity to positive infinity. Now, the next portion that we have to worry about is the actual domain. Okay, when we talk about the domain, for this function, you have to look at the denominator. And in this case, we're going to be looking at the portion that has the actual term at the bottom, which is going to be the 1 plus tangent. Now in this case, we're looking at 1 plus the values of tangent. Is equal to the values of 0. In other words, we're looking at where is the tangent function 0. And in this case, if we were to subtract the values of 1, we're going to be looking at the tangent of x is equal to negative 1. And our function is not going to be defined at all points where the function is negative 1. So in this case, your x value happens to be negative pi over 4. So for the domain, we're actually looking at all real numbers except x cannot equal negative pi over 4. But remember that your tangent function, which I have here, it's periodic with a values of pi. So we would say plus the values of n pi, where n is an integer. And what this is going to give us is all values where we're going to have asymptotes. And let me fix integers. Okay, so let me provide one period of the function. And in this case, one period of the function, it's going to start at negative pi over 4, which I have here. And then I'm just going to add the values of pi. So negative pi over 4 plus the values of pi is going to equal to negative pi over 4 plus 4 pi over 4, which is equal to 3 pi over 4. So that gives us the following two vertical asymptotes, one at negative pi over 4 and the other one at 3 pi over 4, which I have already here placed to scale. Okay, so that's actually it for domain and range of the function, which is what they're asking on the question. The next part, I'm just going to get a couple of points. Since this function is not one of the usual functions that we graph, meaning it doesn't really follow the parent graph, a couple of points and then you would be completing it with technology. And that would be sufficient for the graph. Now, let me start with the actual y-intercept. For your y-intercept, you're going to let x equal to 0. And in this case, your y value, it's going to be an f of 0, which for the function is 1 over 1 plus tangent. So technically 1 over 1 plus the tangent of 0, which in this case is going to be 1 over 1 or 1. Or the coordinate point 0, comma 1, it's going to be our y-intercept. And I already placed that value here, that you can already see there. Now, this is just to get an idea of what the function looks like. As I mentioned, you can complete it with technology. Let me find the x-intercept for this one. Now, the x-intercept we're gonna actually let y equal to 0, but our function, we have it as 1, y is equal to 1 over 1 plus the values of tangent of x. And in this case, give me just a second. What we're gonna do is, since we're gonna be plugging in 0, it's gonna make it a lot easier if you do the substitution of the tangent of x is equal to sine of x over the values of cosine of x. Now, at this point, we're gonna have that y is equal to 1 over 1 plus the values of sine of x over the values of cosine of x. And then what I'm going to do is I'm going to cancel the denominator. Your LCD is equal to the values of cosine of x. So multiply the top by cosine of x, multiply the bottom by cosine of x. And remember that this multiplies every element in the fraction. And we're going to be looking at y is equal to, on the top, you're going to have a cosine of x. And then at the bottom, you're going to have a cosine of x plus the values by the sine of x. The cosine cancels out. And I'm referring to this cosine. So once we carry out that multiplication, your cosine actually is going to cancel out. And at this point, you can actually multiply by the LCD of the remaining function. Once you plug in the values of 0, so we're going to end up with technically 0, it's equal to a values of cosine of x over the values of cosine of x plus sine of x. And then as you simplify to obtain the LCD, we're going to have that this is the cosine of x plus the sine of x. And then on this end, cosine of x plus the sine of x. So we end up with the values of 0 is equal to the values of cosine of x. And this is going to occur at, in this case, I'm just going to say that x is equal to the values of pi over 2. So your actual x-intercept for one period, it's going to be pi over 2, comma 0. And that is technically displayed here. Now, for the rest of the portion of the function, you can just complete it using technology. And this is what I did here. You have technically the asymptotes, which they're there. And then the 2 points that we found are the x-intercept and the y-intercept. After you find at least 1 point, you may complete it with technology and then provide 1 period of it. So I'm okay with 1 period of each function. This one is actually a periodic, so I'll display what it looks like. So in this case, a basic sketch would be sufficient. Our sketch in this case, I'm just going to say that our function does this. And this is going to be for 1 period. So this will be sufficient. After this, it's going to repeat. So the function is just going to do this sort of a behavior on both ends. So it'll do the same on this position. Now, let me display what the function looks like with technology. And this is what the function looks like. So we only graphed this period, but keep in mind that the function keeps repeating and repeating on both ends. Lastly, this is not a common function. So I would expect that you're using technology to graph it, since it doesn't follow exactly what the parent graph does. Okay, that's actually it. So here is once again the work for the x-intercept and then the remaining portion.